Hey guys, Professor Romani again. So today we'll be looking at uniform distribution today. So far we were looking at discrete probability distributions, binomial, Poisson, and hypergeometric. So these were the three distributions which we saw in the previous chapter. So right now in chapter 6, we are moving on with the topic which is continuous probability distributions. Okay, so we're moving from discrete, where you are able to count each outcome, to a continuous form of distribution. Right? So what is a continuous distribution over here? So here, the main thing over here in your previous discrete, in discrete distributions, x can take like discrete values. It could be 0, 1, 2, 3, 4. So x here is like in some sense like a random variable. Right? So you have discrete values and discrete outcomes. There's nothing between 2 and 3. Okay? So whereas when it comes to a continuous distribution, x can take any value between 0 and like 5 or whatever it's say, like, right? Like, so here it could be 0, 0 0.01, it could be 0 0.001, it could be 0 0.0001. Like there are an infinite set of values which lie between the boundaries. And this is, in some sense, a continuous random variable. So in a discrete random variable, in the discrete probability distributions, you could kind of exactly find out what is the probability that your random variable takes the value x, where small x can be like 4. Right? So what is the probability that x is equal to 4? What is the probability that x is equal to 3? These were certain kind of questions which we did see in discrete probability distributions. So these belong to discrete probability. When it comes to continuous, you typically cannot find out what is that x exactly takes a value of 1.0, right? So how can you say, like, let's say you're waiting at a bus stop. Waiting at a bus stop. Right? So and your friend comes along and says, well, how long did you wait before you caught the bus? And you say, 1 minute. Right? I waited just 1 minute. Or let's say it's 10 minutes. I waited 10 minutes before I caught the bus. Well, it's not 10 minutes. And someone is like, hey, let's go a little more granular. You actually waited 10 minutes and 32 seconds, right? And then you could keep going. Oh, you waited 10 minutes, 32 seconds, and then like 780 milliseconds. Well, then you go to like microseconds, and then like nanosecond or whatever. And like you see the point. There's no exact value which you could point. So the probability in continuous probability distributions, the probability that x takes an exact value of like 1 or whatever it is, right? Like, is usually 0. And because this is a continuous distribution, and I know it might be hard to kind of figure this out, but another way to try and think about this, because the exact value is 0, typically in continuous probability distribution, you try and think about, well, what is the likelihood that the random variable that you waited less than 10 minutes? Or you try and think about what is the probability that you waited greater than or equal to 10 minutes? What is the probability that you waited between 5 and 10 minutes? So you kind of ask questions like these in continuous probability distributions. Okay, so with that said, the first distribution which we will be looking at is the uniform probability distribution. So the uniform probability distribution is the distribution where you have an equal likelihood of occurring. Like every part or every area in some sense you can think about it as having an equal likelihood of occurring. So here a simple example is again waiting at a bus stop. Okay, so let's try and think about this local bus. A bus runs every 20 minutes over here, and students arrive at the bus at random times. You just wake up and you just go to the bus stop. You don't know when the bus is arriving. You're not looking at your schedule. You just know it arrives every 20 minutes. You're not looking at the time. You just wake up and you go to the bus stop after you get ready. And the time spent at the waiting at the bus stop follows a uniform distribution. Like equal number of people can wait around less than 1 minute. Equal number of people can wait less than 5 minutes. Like between 1 and 2 minutes, between 2 and 3 minutes, between 3 and 4 minutes. You try and figure out how many people waited how many minutes, it's roughly the same. Like, it's and that is an example of a continuous uniform distribution. Okay, it's continuous because this infinite values between 0 and 20 minutes, but it's also a uniform distribution because there's equal likelihood of a student waiting less than between 0 and 1 minute, or between 1 and 2 minutes, or between 2 and 3 minutes, and so on, so all the way to between 19 and 20 minutes. Okay, so this is an example of a uniform distribution, and it's your simplest distribution because you have equal likelihood. The height, if the y-axis over here is p of x, the probability of the event happening, and x is like here is going to be between 0 and 20 minutes, b is going to be 20 minutes. Okay, so this is just a rectangle, and the height of the rectangle is given by 1 divided by b minus a. Okay, and as always, whenever you try and think about a distribution, you would want to describe the distribution, right? Like, describe the distribution. What's the easy way to describe something? Well, you give its mean and then you give its standard deviation. Right? So these two alone give a long way in terms of thinking about a distribution or any data, or in describing data as well. So the mean of the distribution, since it's a rectangle, it's the exact center point. That's the mean of the distribution. This is just a plus b by 2. And the standard deviation is just given by the difference, b minus a the whole squared, by 12, and you take the square root of that. And that is the standard deviation of this distribution. And similarly, the height of the distribution, as we mentioned, is 1 divided by b minus a. Okay? So given that, if you want to try and figure out how to find, well, let's take the simple example. Well, how much time did someone have to wait? Like, what is the probability that someone waited less than 10 minutes? This is a question which you want to answer. The way you try and think about that is, if this is the 10-minute mark, what is the area in this orange sector, with the center point being 10? To draw it. Okay, so this is 0 minutes, which is A, and this is B, which was 20 minutes. And the mean was 10 minutes. Okay, and that's like you could have 5 minutes even. Let's try and ask for another question. 10 minutes, so what is the probability that someone was waiting less than 10 minutes as the area left to this 10 minutes? That means it's this shaded area over here. So the area of this part is going to be the probability that someone waited less than 10 minutes. And okay, that's going to be this blue area. And how do you find that out? Well, let's find out the height. What is the height? The height of the distribution is 1 divided by b minus a, which is 1 divided by 20 minus 0, 1 by 20. Okay. So the area, the blue area, you could think about it. The blue area is the probability that x is less than 10 minutes, that someone waited less than 10 minutes. Okay. And that is found out by, this blue area is found out by what is the area of a rectangle? It's like the base into height. Okay. So that's how you find out the area. It's given somewhere here. It's base into height. And so what's the base over here? Base is 0 to 10, which is like 10. And your height is 1 by 20. So in this scenario, this is straightforward. Your probability someone arrives less than 10 minutes is half. Let's try and find out the probability that someone waits less than 5 minutes. And this can be thought of as base into height again. The probability that someone is less than 5 minutes is going to be just this area over here. You can change the color. Green area over here. That's the probability that someone waited less than 5 minutes, and that will be given by, so base is 5 in the scenario, and your height is 1 by 20. This is 5 by 20, which is 1 by 4. Okay. And this, in some sense, is your uniform continuous distribution. Every time you try and think about any probability, what is the probability that something is less than or greater than or equal to, try and visualize a picture, get the distribution, whether it's however the distribution is, right? The distribution could be something like this. Distribution could be something like standard normal distribution. Distribution could be like a uniform distribution. Whatever the distribution is, once you find that out and you plot these numbers, the area under the curve roughly corresponds to the probability that something will occur in that. Probability that the event, the random variable, is between these 2 points. Okay, so that's the way, that simplifies your way of probability thinking. And in your next class on Friday, we will be talking about this uniform, the standard normal distribution and the normal distribution and all its properties. Okay, I'll see you all in class. Bye bye.